All right, it's been a few days, but let's try to do some more proofs. This one is coming from 8.5a. 8.5 is where we learn reductio ad absurdum. This is going to be practice at A. Number 15, it's all on page 402. Let's see. We're trying to prove a disjunction. We have a not A or B. We have not A there, we have B there. Now, because this is a disjunction, of course, if we get one of the sides, we could just add the other side. Since this chapter is on reductio ad absurdum, I don't think I've done any videos on reductio ad absurdum. So let's go ahead and try to do reductio on this one. So let's go ahead and assume then. So let's think about our strategy. We're trying to get this, not A or B. If we were going to use reductio to get this, here's how reductio works. We assume the opposite of what we're trying to prove. So that's going to be the negation of what we're trying to prove. So we write what we're trying to prove, and then we put parentheses around it and put a negation out front. That's the opposite. Now, if what we've assumed leads to a contradiction, and it could be any contradiction. It doesn't have to involve A, it could involve Q, it could involve T. It doesn't matter what the contradiction is. But as long as our assumption entails a contradiction, we know it's false. Anything that entails a contradiction has to be false. And so if we're able to do that, then since this is false, we know the opposite of it is going to be true. So that's how reductio ad absurdum works. So since we're trying to prove this, let's assume the opposite of it and see if that leads to a contradiction. So a negation of what we're trying to get assume for reductio ad absurdum. And now our goal inside this box is to get a contradiction, any contradiction. Once we do that, we can conclude that this is false, so that the opposite of this, which is just going to be everything inside this parentheses, then that will be true. So let's see if we can do that. All right. We don't have a whole lot to work with, but the first thing I notice is that this is not a very nice statement. When I have a statement that has some things in parentheses and a negation out front, usually that's very hard to work with. There's not a whole lot you can do with it. So a good tip is when you have something like this, a negation of a big, longer statement, you want to somehow get rid of that negation out front. Make it easier to work with, to where there's more things you can do with it. And when the thing inside the parentheses is a disjunction, then that's perfect for De Morgan's. So let's do De Morgan's to 5. If we do that, there's of course two things that we need to do with De Morgan's. We distribute this negation to both sides of the disjunction, and we flip the V to a dot. We flip it from a disjunction to a conjunction. So let's do that. We apply the negation to the A side, and this is going to flip from a V to an and to a dot, and we have to apply the negation to the other side. Awesome. now what we've got is actually very easy to work with. Since it's a conjunction, it's this and that, we can easily just simplify, which gives us things that are very easy to work with. The simpler the statement, usually the more things you can do with it. So 6, simplification. So now we have things that are much easier to work with. For example, we have not A. What could we do with that? Well, we see a not A there. If we were going to do something with 2 and 7, that's actually perfect for modus tollens, because for modus tollens, you need the negation of what's ever on the right side of the arrow. Since not A is on the right side of the arrow, to use modus tollens, we need the negation of not A, which is not A. So that's perfect. So 2, 7, modus tollens, and the output there is going to be not Q. Awesome. Now, notice, since we've achieved not Q, we look up where we might have another not Q. We have it in 1. And hopefully that reminds you of the rule of modus ponens. So we could apply modus ponens to 1 and 9. That's going to give us the right side of this arrow. So it's going to give us L arrow F. If L, then F. What can we do with our new line? Well, if we look what we have, we notice line 4, we have L, and so we could also do modus ponens with these two lines, 10 and 4. Modus ponens, and that's, of course, going to give us F. All right. Oh, we're working right along. We just got F. If we look up here, we have if F, then B. So that means we can conclude B from 3:11. Modus ponens. Modus ponens is a classic rule. You're going to use it a lot, probably. All right. So now we have B. We're trying to get a contradiction. What should we do next? Well, one good strategy is to think about what lines you have not yet used to get a further inference. So you can look at your numbers over here. Have we used 1? Yes. 2? Yes. 3? Yes. We used 4? Yes. 5? Yeah. 6? 7? Have we used 8? No, I don't think we've used 8. What's 8? Not B. Oh, look at that. Since our goal is to get a contradiction, any contradiction inside this box, notice that we have not B, and we also have B. That's the perfect setup for a contradiction. So we can get, by conjunction, we'll get B and not B, which is going to be 12 and 8 conjunction. So now we've shown that if we assume this, that leads to a contradiction. So we know that our assumption, number 5, it has to be false. So if this is false, then that allows us to conclude that the opposite of this is true, which is going to be not A or B. And that maneuver is going to be reductio ad absurdum. So we cite the lines 5 through 13, reductio ad absurdum. We've reduced our assumption to absurdity, to a contradiction. So that's where it gets its name, reductio ad absurdum. Reduce an assumption to absurdity. which shows the assumption to be false. So the opposite of the assumption, which is 14, has to be true. Awesome.